Now that we know how to add, subtract, and multiply complex numbers, we are going to look at how to divide complex numbers. So it's important that you know how to write a complex number in the a plus bi form, where you have a constant plus a coefficient in front of the I. So there's two terms here. There's a term with, there's a constant, and then there's a term with the imaginary number. So we call this the real part and the imaginary part. So for example, if we have 9 minus 6i divided by 2, we would want to rewrite that in a plus bi form. So anytime that you get an answer, a final answer in any of the problems, you want to make sure that you take that answer and rewrite it in a plus bi form. And the way that you do that is that you separate the quotient. So for example, this will become 9 over 2 minus 6 over 2i. So notice that the denominator just got split. So you have your a part, your real part, and you have your imaginary part. Notice that we kept the operation of subtraction in between them. From here, you'll try to simplify. 9 over 2 is already simplified. However, 6 over 2 will reduce to 3, which gives us our answer 9 over 2 minus 3i, which is now written in a plus bi form. So i's are not allowed in the denominator ever. So it's just like when you were working with radicals. Radicals were not ever allowed in the denominator, and we had to rationalize. So same things with complex numbers. We never want an I in the denominator, and when we do have one, we want to rationalize. So we want to remember that I is the same as the square root of -1. And if we were to replace I with the square root of -1 and think, oh no, we can't have a radical in the denominator, we would multiply by itself. So likewise, we would want to make I squared so that way we can have -1. So in order to get the I out of the denominator, we're going to rationalize it by multiplying by I. So let's try an example. Let's say I have 3 over 4i. Yikes, I cannot have that I in the denominator, so I'm going to rationalize this by multiplying the numerator and the denominator by I. In the numerator, I end up with 3i, and the denominator, I end up with 4i squared. However, we know that I squared is the same as -1, which leaves me -3 over 4i. All right, let's do -13 over 5i. So we'll multiply top and bottom by I. This is called rationalizing the denominator. So I end up with -13i over 5i squared. The I squared becomes -1, which means that my fraction simplifies to positive 13 over 5i. Since I have a negative over a negative, I ended up with positive. All right, you go ahead and try one. Okay, you should have gotten option number 3. If you would have multiplied I to the top and the bottom, you would have gotten 6i on top, and you got an 11i squared, which is 11 times -1 on bottom, giving you a final answer of -6 over 11i. All right, let's try another one. All right, you should have gotten option number 2, 2 over 3i. So if you would have multiplied I by top and bottom, you would have gotten -4i on top and 6i squared on bottom, which is the same as 6 times -1. So since you have a negative on top and a negative on bottom, you end up with a positive number. And then 4 over 6 reduces to 2 over 3. All right, let's try this one. I multiply the top and the bottom by I. Notice that I actually have a binomial in the numerator. I have a 3 minus 5i. So when I multiply by I actually have to distribute the I to both terms. So I end up with 3i minus 5i squared on top, and then 6i squared in the denominator. So from there, the I squares become -1s, And then I'll simplify a little bit. I have 3i minus 5 times negative 1, which becomes 3i plus 5. And then 6 times negative 1 becomes negative 6. Now remember, I need to rewrite this in the a plus bi form. So that would become 5 over negative 6 plus 3 over negative 6i. Notice that I put the real part without the imaginary number first, and then the imaginary number part. Now, 3 over 6 reduces, so my final answer becomes negative 5 over 6 minus, because this was negative and plus and negative is the same as saying subtract, 1/2, because 3 over 6 reduces to 1/2 I. All right, you try one like the previous question. Okay, you should have gotten option number 1. If you multiplied by I in the numerator and the denominator, you would have gotten negative 1i plus 4i squared divided by 6i squared. And then the I squares would become negative 1. And so that means you would have negative 1i plus negative 4 over negative 6. Now, we would distribute the denominator to the real number and the imaginary number. So we would have negative 1i divided by negative 6. So that's where we get the negative 16i. And then we would have negative 4 divided by negative 6, which is where we get the negative 2/3, because 4 over 6 reduces to 2 over 3. Okay, so let's review. What can you multiply the denominator to get rid of I? Well, we said it, I. However, if you have a binomial in your denominator, if I were to multiply by I wouldn't be getting rid of I. Because, think about it, if I multiply the top and the bottom by I, typically, if I just had I, that would become I squared, which would become negative 1. But now that I have the 4 here, I would also have to multiply the 4 by I. So I would have 4i plus negative 1, which means I would still have an I in the denominator, in which I would then have to multiply by I again, and we would go round and round and round, and it's a never-ending circle. So, just like when we had radicals and we had a binomial in the denominator, we had to multiply it by the conjugate in order for us to rationalize the denominator, which is what we're going to have to do with complex numbers. So, remember, the conjugate is going to be the same terms, but you're going to switch the operation. So you're still going to have the a plus bi, your imaginary number, but then you're going to have a minus bi, and that would be the conjugate. So let's try this. What do you think the conjugate of 4 plus 6i is? You should have gotten 4 minus 6i. One more. Let's do this one. Negative 3 plus 2i. What would be the conjugate? You should have gotten negative 3 minus 2i. Notice the sign doesn't change on my first term. The only sign that changes is the sign in the middle. All right, so when we rationalize the denominator, we're going to multiply the top and the bottom by the conjugate. So this is 4 plus I, which means I'm going to multiply my top and my bottom by 4 minus I, which is the conjugate. And so when I multiply 11 plus 7i times 4 minus I can either do the FOIL method or I can do the box method. So I would get 44 plus 28i minus 11i plus 7 on the top, which reduced to 51 plus 17i. And that would be my numerator. In my denominator, I would end up with 16 plus 4i minus 4i plus 1. And so that would give me 17 for my denominator. So So then I would have 51 plus 17i divided by 17. So then I'll distribute the denominator now that there's 1. So I'd have to 51 over 17 plus 17i over 17. Well, 17 goes into 51 3 times, which is how I get the 3. And then 17i divided by 17 leaves me I. Why don't you go ahead and try a problem on your own? So we have 3 minus 5i divided by 2 minus I. You should have gotten option number 3, 11 over 5 minus 7 over 5i. So you should have multiplied by the conjugate, which would have been 2 plus I on the top and the bottom. So if you did that, you would have ended up with 11 over 5 minus 7 over 5i. One more. All right, you should have multiplied by the conjugate 2 plus I. And by doing so, top and bottom, and then either doing the FOIL method or the box method on top and bottom, and you would end up with 3 over 5 plus 4 over 5i.